Okay, so let's look at part two. Let's get into the geometric proofs. So these are the three properties of geometry, and we're going to need them. You have the notes. You can just copy these down. And so, what are we doing? What are we doing for literally the next month or so? We're going to do a proof. So, what is a proof? A proof is a succession of statements that lead to a conclusion. Now, you're used to doing proofs in algebra. I give you an equation, and the last step is x equals 5. And so you've proved, that's the idea. You started off with a statement, and you kept moving into the last statement. First of all, it's a succession of statements. All the statements are all of these are true. So there's not going to be a question of, is this proposition, is it indeterminate? No, everything is true. And so there's going to be one exception when we look at an indirect proof, but in general, everything is true. Yeah. Okay. Two things. We're going to construct our proofs, all of math, based on postulates and theorems. Now, another name for postulate is axiom. And an axiom or a postulate is basically a statement that's accepted as true. Accepted as true. We're just accepting it's true. A equals A. If A equals B, then B equals A. And if A implies B and B implies C, then A implies C. We're accepting that as true. And so as we go through the course, I will put a statement on the board and I will say axiom or theorem. What's a theorem? It's a statement that we have to prove true. A statement that must be proven true. Okay. Now, how are we going to do? Well, these are some theorems. So these are going to be our axioms that we're going to build off of everything. We also have the properties of equality from the video that we watched last. Okay. Well, how are we going to do this? We're going to use a 2-column proof. We're going to use a 2-column proof. And it's going to look something like this, right? And so on the left, can you see me? Yeah. Can you see the board? Yeah. On the left, we're going to write a statement. On the right, we're going to write a reason. Okay. Are you ready? Are you ready for, let me move the video over so you can see me. Is everyone ready for your first proof? Let's begin. Theorem 1. All right angles are congruent. Is that a theorem or a postulate? It's a theorem. We have to prove it. How do we prove that every single right angle is congruent? Well, we can start off with a given. 1. A equals 90 degrees. B equals 90 degrees. So this is our statement. This is our reason. Why is this true? Given. Number 2. If angle B equals 90 degrees, then 90 degrees equals angle B. Is that true? Why? Symmetry. Three. Angle B equals 90 degrees, and 90 degrees equals angle B, then angle A is congruent to angle B. Why? Transitive. Transitivity, chain rule, and we're done. Are we finished? Yes, we just proved that every single right angle is congruent to each other. Now, when you finish a proof, this is really old school. You write QED. And you just did your first proof. Ready for the next proof? Vertical angles are congruent. Theorem 2. Vertical angles are congruent. Sorry. Okay, well, I'm going to draw a little diagram over here. Am I recording? Yes, I'm going to draw a little diagram over here. And I'm going to call this line L, and I'm going to call this line M, and I'm going to call this point P, and I'm going to say, right, that lines L and M intersect at P. Why? Given. And what I'm also going to do to make my life a little easier is I'm going to put numbers in here. So what's the idea? So the idea is prove. What do you have to prove? Well, we have to prove that angle 1 is congruent to angle 3. Right? Okay. What do you think? Well, number 2. Angle 1 plus angle 2 is equal to 180 degrees. Angle 2 plus angle 3 is equal to 180 degrees. Why? 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 Definition of linear pair. Now, even at this early stage, we're going to sip a little step. What do you think is next? Actually, I'm going to make you do a little work today for the proof. What's next? Okay, number 3. 180 degrees equals angle 2 plus angle 3. Symmetry. What's next? Angle 1 plus angle 2 is congruent to angle 2 plus angle 3. Transitive. What's next? Ready? Angle 2 is congruent to angle 2. Why? Reflexive. What's next? Angle 1 plus angle 2 minus angle 2 is congruent to angle 2 plus angle 3 minus angle 2. Subtraction, property of equality. Next, angle 1 is equal to angle 3. we're just going to say substitution. And we're done. We're finished. And what we've shown is that vertical angles are congruent. Now, the great thing about in this class is once we've proved something, we don't have to prove it again. We can now use it for application. So if you look through like Unit 2.4, you see, it talks a lot about proof, but then in the problems at the end of the book, at the end of the unit, it's all like solve this algebra problem. But in this class, we're proving all the behind the scenes. Let's move on. Theorem 3. Theorem 3. Theorem 3 says supplements to the same angle are congruent. Now, it's interesting because you might say, hey, Mr. Adler, like, we already did this because 1 and 3 are supplements to the same angle, therefore they're congruent. But this is specific for vertical angles. What happens if, so for example, you're going to see in this problem, in the future, so the question, I'm sorry. So what you're going to see in a future problem is, sorry about it. Theorem 3. Supplements to the same angle. Sorry about that. Supplements to the same angle are congruent. So let's just do the proof first, and we'll see how is it different than the vertical angles one. Well, line 1, I say angle 1 plus angle 3 equals 180 degrees. And angle 2 plus angle 3 equals 180. You know what? Let me use different letters. Let me use A, B, and C. Angle A plus angle B equals 180 degrees. And angle C plus angle B equals 180 degrees. And we want to prove that angle A is congruent to angle C. Once again, you're looking and saying, Mr. Allen, we just did that. But no, here's an example of a problem that's going to be showing up in like a month. Here's an isosceles triangle, okay? Here's an isosceles triangle. I'm going to tell you it's isosceles. You're going to have these two sides are going to be congruent. We're going to discuss the fact that the base angles are congruent, and I'm going to say prove that angle 1 is congruent to angle 2. And so the idea is that 1 is supplementary to this angle, and 2 is supplementary to an angle congruent, and we're going to use this theorem to prove they're congruent. Supplements to the same angle are congruent. Same idea, but once again, they don't necessarily need to be a linear pair. So we go through the steps. We go through the steps again. Line, this is given. What's going on with 2? Well, we can kind of pick up the pace a little bit. Angle B is equal to angle C plus angle B. Transitive. And then number 3 is angle A is congruent to angle C. Subtraction postulate. Actually, sorry about that, guys. Let me put in the next step. Angle A plus angle B minus angle B is equal to angle C plus angle B minus angle B. This is subtraction postulate. Property of equality. And then number 4 is simply angle A is congruent to angle C. Substitution. Substitution. And so what we've shown is that if 2 angles are supplement to the same angle, then they are congruent. Try this last one. last theorem for today. Last theorem for today, and we're going to be really going over this every single day. So after a while, you'll get used to this. Okay, here's a problem. Ready? You like this? Can you see me? Last one. Given a segment A, B, C, D. Given if AB is congruent to CD, prove that AC is congruent to BD. Now, once again, some of you might look at this and say, oh, well, it's obvious, I can see it. But once again, we're going step by step, slowly but surely. Okay? So I want you to think about this. How can we prove this in a two-column proof? Okay. Once again, we're not in an English class. I'm not seeing an essay. I want to see a line-by-line proof. Okay. Step 1, AB is congruent to CD. Why? Given. Number 2, what do you think? Okay, BC is congruent to BC. Why? Reflexive. Number 3, AB plus BC is equal to CD. Let's make it BC plus CD. What do you think? Addition postulate of equality. And then the last, I'm sorry, give me 1 second. I apologize, guys. What is the last, what do you think? What do you think the last line is? Oh, sorry, I apologize. What do you think the last line is? Well, the last one is, sorry guys, AC is congruent to BD. And that's the segment addition postulate. Now you can write that, or you can write substitution. Because we know that AP plus BC is AC, and we know that BC plus CD is BC. So either segment addition postulate or substitution is fine. And we're done.